Good day, students. Welcome back. Lesson 3, last part, Part D. We've talked about this often in our videos. We've looked at independence and dependence, and it's a tricky topic for students. We'll get it now here in Lessons 2 and 3. When we move on to probability, we're going to review it. It's going to be the same material sort of looked at from a different angle. But in this last lesson, Part D, let's get some formal ideas of independence, dependence, and hopefully since we've done so many examples, things should make sense. Remember, ask your instructors for help when you need it. We want to make sure that we're understanding the material. All right. I have more of a casual definition of independence, but I think this will do the job. Two variables would be independent if the values of one of them do not affect the values of the other. So independence means they're separated. One has no impact on the other. Independent variables are unrelated, is another way that you could think about it. All right. So an example of independent variables. Let's say at Cecil College, the variables gender and age are independent. And in all likelihood, they are independent. If I told you that I know this student and the student's 25 years old, would that give you any clues as to whether they're male or female? Probably not, right? Because age and gender, in all likelihood, really don't impact each other for our students at Cecil College. Question, we know that roughly 2/3 of students at Cecil are female, leaving 1/3 males. Okay, so I think there's a couple, A and B here. If I restrict ourselves to just looking at the 20-year-old students, what percentage will be female or should be female? Because the variables are independent, close to 2/3 of the 20-year-olds should be female. Because they're independent. If I tell you I know the student, and the student happens to be 20 years old, should that change the breakdown of female-male here at the college? In all likelihood not, okay, unless something really funny happened. So we would expect 2/3 of the 20-year-olds to be female, leaving 1/3 of the 20-year-olds to be male. In Part B, it's the same, but we'll go up to 35-year-olds. If we look at the population at Cecil College of just the 35-year-olds, there's probably a few dozen 35-year-old students. What proportion do we expect to be male? We expect 1/3 to be male. And consequently, we would expect 2/3 to be female. It's because age doesn't matter. It's because age is independent of gender in all likelihood at Cecil College. It'd be really weird if we looked at the 35-year-olds and we found 80% female and only 20% male. I would be very amazed if that was the case. I'm guessing it wouldn't matter. So that's independence. Dependence is the opposite. Again, we'll have a casual definition. Two variables are said to be dependent if the values of one affect the values of the other. Dependent variables are related in some way. Okay, so let's think of some dependent variables. We'll look to gender again at Cecil College. Gender, and here's a variable. Engineering major or not an engineering major. These are definitely dependent. Only 1/3 of our students at Cecil College are male, but just walk into any Calc 3 class, any linear algebra or engineering course, and you are likely to see over 80% of the students to be males. Okay? There's a dependency there. For whatever reasons, whether it's tradition or just natural instincts or who knows what, and it's not right or wrong, but in the engineering field, males gravitate towards it. You'll see a much higher percentage of males than females. I've taught linear algebra for 4 semesters, 4 years. I think I've had exactly 2 female students over 4 years. So there's some empirical evidence sort of backing this up, right? There's a dependency there. Let's go to nursing. Now the variable is whether or not you're a nursing major. My wife's currently in the program, and I said, wife, what percentage of your classmates are female? She said, well over 90%. 9 out of 10 females, just a few males in the whole program. Again, dependent, this is an opposite direction. Okay? Typically, females hold over 90% of those spots. If nursing was independent of gender, we would see that same 1/3, 2/3 breakdown in gender up in the nursing program. You would see 1/3 of your classmates males, but it's not the case. There is a dependency there. Okay? Last one, I tried to pick a major that would be independent. Are you a business major? I'm guessing if I went to business classes, looked at the rosters, I'm guessing that at Cecil College, about 2/3 of the business majors are female and about 1/3 of the business majors are male. I think that one is gender independent. I don't know for sure. We'd have to collect the data to analyze it, but if you're making me guess, and you are because here I am on film, I would say independent. How can I tell with a contingency table if variables are dependent? We've done this many times. I had a hard time doing this, but I wanted to put it in print for the notes. What are the steps I need to take to show independence versus dependence? And we've done it. And even if we didn't know what we were doing, we were looking at a marginal distribution and comparing it to a conditional distribution. So what we'll do, I'll just sort of summarize this. We'll first compute marginal proportions by either looking at row totals or column totals in a contingency table. This would be the marginal distribution if we do it for the whole table. Once we look at that marginal distribution, we will compare it to a conditional distribution, only looking at one column or one row at a time. And basically, you're comparing the two. Okay? Now, in words, we did it for nursing versus gender. And in words, we did it for engineering versus gender. We looked at the whole school, and then we compared it to males and to females to see if there was a difference or if they were the same. Okay? When there's a big difference, that's when there's dependency. When there's really no difference, that's when we have independent variables. Okay, so I did a pretty crass job of summarizing this, but you've got it in the notes. We've probably done it 8 times already, at least on the videos, probably another 8 times in class. So let's practice one more time and we'll see what we mean here. We'll go back to our New York Police Department data sets. Here's a contingency table. I have race as one variable up top. We're still working with categorical variables. The New York Police Department has 6 race categories, and then I have whether or not you were frisked. I'd like to know if the chances of you being frisked depend on your race. Are certain races more or less likely to be frisked? Okay, and we've got the data to support this. Let's see what the heck the questions are. Part A, give the marginal distribution for whether or not a person was frisked. Marginal distribution. The root word is margin. All I want is the yes-no breakdown, but for everybody. So I'm going way over here to the margins. Look at the totals. I see about 29,500 were not frisked. I see about 37,500 were frisked. What's that breakdown? All right, where should we squeeze this? Maybe down here at the bottom. Okay, so whether you were frisked, either you weren't or you were. So here's no and here's yes. For the no's, I've got the 29,563 over the grand total, 67,235. Of course, we can't do that in our heads. We go to the calculator. It's 4397. 0.4397. I'll just leave that as a proportion. I can make this 43.97%, but guess what? There's no room left, so we'll leave it like that. For the S's, 37,672 up top over the grand total, 67,235. I know this is going to be about 56% because those two have to add up to 100. I've used up about 44 here with the nose, And as a decimal, 0.5603. This is a marginal distribution. It's looking at everybody that was frisked, okay, whether or not that you were, and everybody that was questioned by police. What we're going to do, Part B, I'll go to the sideboard. Quickly, we'll look at every race, and we'll start looking for differences. Are some races more or less likely to be frisked? If there's differences, that will mean dependence. I'm comparing a marginal to conditionals. If they're all approximately the same, it'll be independent. All right, so let's see. We'll flip the page in the notes. We'll just come over here to the side. This is Part B. And, well, we'll go left to right across the table. Here's American Indian. We're going to try to slam out all 6 of these here. The American Indians, total, there were 287, you can see at the bottom of the first column. So, frisked, no. It's 158 out of 287. Make sure you can find these 2 numbers on the table. I know the table is not on the video screen, but you've got it right in front of you. 158 out of 287. So, of the American Indians, about 55 point. Well, let me keep them as proportions just to be consistent. 0.551 not frisked. Look to the S. Let's see, 129 were frisked out of 287. These will always add up to 100%, so this should be 449. 0.449. Okay, yes frisked and no frisked. I'm looking on the screen, but we won't move the camera. That's very different than the overall general population. General population, 44% were not frisked, where about 56% were. And so if I look just at the American Indians, there is quite a big difference there. They're just about reversed. That difference compared to the marginal is telling me there is a dependency. This seems to be a pretty substantial difference. All right, so now all we're going to do quickly is we're going to work our way through the table. We'll do Asian, black, black Hispanic, white, white Hispanic. And we're going to go lightning speed. So here we go. Next one, Asian. Again, no and yes. I've got the numbers here. So of the Asians, for no's, 1156 out of 2101. For the yeses, 945 out of 2101. Percentages as decimals. This is about 550. This is about 0.450. So if I look at Asians, there's the no-yes breakdown, whether or not you were frisked. Oh, I can squeeze in black right here. Just have to write a bit smaller. For the no's, I had 15,505 out of 36,548. Divided out for the no's, 0.424. For the yeses, for my black folks, 21, 0, 43 over 36, 548. Leaving them all as decimals, that's about 57.6. You can see, are all of these the same? They're sure not, right? If I am an American Indian or an Asian person, it's much less likely that I'm frisked compared to if I am black up in New York City. Okay? And keep in mind, the data we're working with is real data. Everything in the notes, there are data sets that we found because they're interesting to analyze. Okay? We're looking for patterns, we're seeing them. Last 3, ludicrous speed, black Hispanic. Cubs here, again, same breakdown, no and yes. You can pause the video at home. 19, 32 over 49. 32, that total is 0.392. If I go to the yeses, 3,000 over 49. 32, that is 0.608. Huge differences here compared to what we're used to. Next comes white. Whites were again at the nose, 3420, over 59, 97. That is 0.570, 57% of whites were not frisked. Yeses, 25, 77, over 59. 97, that's about 43%, 0.430 were frisked. Huge differences looking at across the races. The last one, students, white Hispanic. 73, 92, over 17, 370 is 0.426. So white Hispanic, not frisked, 42.6%. White Hispanic, yes frisked, 99, 78, over 17, 370. That is 57.3% rounded. All I did was work my way across the 6 columns. Independents, these would all be the same. It'd be the same breakdown as the overall breakdown if they were independents. But you can see differences here. Those differences are telling me dependent. I'm comparing conditionals to a marginal. Once I find one difference that kills independence, one big difference, and I have dependence. And we have it. All right, we'll go to the sideboard here. I've said it probably 8 times already, but Part C, are race and being frisked independent or dependent? Part C, this is a big fat dependent, exclamation mark, and how can I support that? You've got the supporting numbers from Part B, but all the conditional distributions based on race differ substantially. Because they differ, it's dependent. Okay, if they were all approximately the same, then race really wouldn't matter. But they do differ, so we do have a dependency here. All right, I believe that wraps up all of the videos in Lesson 3. So thanks for watching. We'll see you in class, and take care.